Hi, in this video we'll be talking about generator expressions. It's by all means recommended that you watch my video on generators and the one on list comprehensions before you go on with this video. Now we can code simple generators as expressions. The syntax is very much like in list comprehensions, but instead of the square brackets we use parentheses. We choose this option if we want to use the generator right away and its task is not too complicated. While list comprehensions return lists, generator comprehensions return generators. Here are some simple examples. First, we'll use a generator expression to generate the squares of all the numbers less than 10. So, squares equals parentheses I times I for I in range 10. And now we can use the next function like so. Next squares 0. Then we have 1, 4, 9, 16, 25. These are the squares. 36, 49, 64, 81. And now, stop iteration, because 81 is the square of 9, and 9 is the last number less than 10. The next example is just a little bit more complicated. Here we have a list of names, and what we want is a list of all the letters that make up the last names, so Hopkins, Smith, and Clarence. And if we pass a generator expression to the built-in list function, it's equivalent to using a list comprehension in the first place. Let's have a look. Letters equals list, letter for name, in names for letter in name split with index 1. So name split splits each name to a list of two elements, where the first name is the first element and the last name is the second element. And what we need is the second element, so the element with index 1. So this means for letter in this, and this last name. So to sign up, this generator expression should return for each of the three names the letters of the last name. Here, here, and here. Let's print it out. Letters. And here we have the letters that make up the last names in these three names: Hopkins, Smith, and Clarence. Another example. Here we have a list of words, and what we need are the first parts of these words, the first halves. If the number of letters is odd, we'll get less than half, so 2 letters in this case. And if the number of letters is even, we'll get the exact half of the word, so the first 2 letters here, for example. Okay? And now let's use a generator expression. Halves equals word sliced from the beginning to the length of word divided by 2, and this is converted to an integer. So this for word in words. Okay, let's print halves. As you can see, it's a generator object. Now, if we need all the halves at once, we have to use the list function. So list halves, and now we get all the elements. We can pass a generator expression as an argument to a function. Then we can drop the parentheses enclosing the expression. Have a look. Sum n for n in range 5, 10. But we can't drop the parentheses if the generator expression is not the only item enclosed in the parentheses of the function. Otherwise, we'll get an error. Let's have a look at the sorted function, for example. Sorted n for n in range 5, and for example, reverse equals true. Well, this won't work because generator expression must be parenthesized if not sole argument. And as we can see, the generator expression is not the only argument here. We have two arguments, this and this. So, for this to work, we'd have to rewrite this as follows. Here we need parentheses. And now it'll work. Fine. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.